Hi everyone, this video goes over 95% confidence interval. To create a 95% confidence interval, we are going to take the mean and we're going to add and subtract 2 standard deviations. That'll create an interval where the 95% of the data falls. If a data point falls inside the interval, then it is ordinary. It's not significant. If it falls outside of the interval, that is unusual or significant, because you're like, wow, that's significant because it's so unusual. All right, so some questions will ask you just to create an interval, and some questions will ask you a follow-up question of like, is some random result significant or not significant, or is it unusual or not, something like that. So the first one says, in a small city, there are 22 gas stations. The mean price for a regular gallon of gas was $2.12 with a standard deviation of 5 cents. The distribution of the data was approximately normal. Given this information, the middle 95% of gas stations in this small city is likely to charge middle 95%. Whenever you see the 95%, this is what you're going to do. If you see mean, standard deviation, and 95%, those three things together are telling you confidence interval. So you're going to take the mean, $2.12, and you're going to add and subtract 2 of the standard deviations. When I say 2 of them, I'm going to do 2 times the standard deviation. So the standard deviation is 5 cents. Now I have my calculator on my iPad because I don't have my regular calculator with me right now. So $2.12, whoops, plus 2 of the 5 cents. And then also $2.12 minus 2 of the 5 cents. So we've got 222 and 202. So somewhere between 202. Now usually we write it as in an interval. We would write 202 since that was the lower answer, and then 222 for the higher answer. But sometimes I just write it like this, 202, 222. Now this is dollars, and all it's looking for is the interval. You don't have to do any of this extra stuff, so it's just option 3. Let's look at one that's set up differently. So this is a short answer question. A grocery store orders 50 bags of oranges from a company's distribution center. The bags have a mean weight of 3.85 pounds per bag. The company claims that their bags of oranges have a mean weight of 4 pounds. The grocery store ran a simulation of 50 bags 2,500 times, assuming a mean of 4 pounds. The results are shown below. So all of these bars represent how many times, like the mean that they got after simulating weighing 50 bags. So like it pretended it weighed 50 bags, right? It got a mean and then it plotted a point. And then if it got that mean again, like 3.98, it would plot another point at 3.98, making the bar even higher. And then if it got another mean of 3.98, it would make the bar even higher. This was simulated 2,500 times. So the total of these bars is supposed to add up to 2,500. Anyways, what you really want to focus on is in the corner, this is what you're going to use for your 95% confidence interval, whatever the results of the simulation are. Okay, so we've got, is the mean weight of the grocery store sample unusual? Explain using the results of the simulation. So we're going to do the mean, 4.001, plus or minus 2 of the standard deviations. 4.001 plus 2 times 0.026 on my giant calculator is 4.053. And then I'm going to do that again, but with a minus. So minus 2 times 0.026. All right. So these are my values, 3.949 and 4.053. Now, I threw them into my calculator like this, but so the interval, the lower value is 3.949 and the higher value is 4.053. So the question is the mean weight of the grocery store sample unusual? So whatever they're referring to down here in a short answer question, usually you have to find that information back up in like the blurb. So the mean weight of the grocery store sample is there where we underlined it, 3.85. So is 3.85 in this interval or is it out of this interval? 3.85 would be before 3.949, so it's outside the interval. So it is unusual. The mean weight of 3.85 is unusual because it falls outside the 95% confidence interval. All right, let's try another one. In a packaging plant, a machine packs boxes with jars. The machine's manufacturer states that a box is packed on average every 42 seconds. To test that claim, the packaging plant randomly selects a sample of 10 boxes and finds the sample mean to be 49.8 seconds. The company ran a simulation of 1,000 trials based on the manufacturer's claim. The approximately normal results are shown below. So you have this simulation. There's 1,000 dots. Since there were 1,000 trials, this represents 1,000 dots. Based on the simulation, determine an interval containing the middle 95% of plausible mean values. So this 95%, that's supposed to be confidence interval. Round your answer to the nearest hundredth. Okay, this one is the first one with rounding. So let's pay attention to that because we're going to use this, the mean and standard deviation, to create our confidence interval. This is what we want to use. So we're going to take the mean. Oh, by the way, n equals 10. N is just like that every sample was 10. I don't know why they put that there sometimes and other times they don't, but really just focus on the mean and the standard deviation. So we're going to take the mean 42.029. We're going to add and subtract 2 of the standard deviations. So 42.029 plus 2 times 3.105 gives us, 48.239, and then 42.029 minus 2 times 3.105 is 35.819. Now notice, I did not round correctly right now, so when I write my interval, that's when I'm going to do my rounding, but you could round whenever you wanted. Nearest hundredth, so I'm putting the lower number first for my interval, 35.8. This one is going to turn to a 2. And then 48.24. Is the time 49.8 seconds unusual? So that's what they had gotten up here, the sample mean to be 49.8. Is it unusual? 49.8, is it in the interval or outside of the interval? It is bigger than 48, so it's going to be outside the interval. So yes, it's unusual because it falls outside the 95% confidence interval. All right. If it was normal, it would be inside the interval. Let's try another one. A sporting goods manufacturer is trying to determine if they should continue to produce multiple types of hockey pucks. the company surveyed 50 randomly chosen customers and asked them if they purchased both game regulation pucks and lighter training pucks. Of those surveyed, 40 of them said that they purchased both types of pucks. A simulation that was run 100 times based on the survey results produced the approximately normal results below. You've got your simulation. This one has 100 dots on it. The mean and the standard deviation are right here. This should stick out to you. Determine an interval containing the middle 95% of plausible values, here we go again, that estimate the proportion of all customers who would purchase both types of pucks from the company. So we've got mean, standard deviation, we've got a simulation, we see 95%. This is a no-brainer. So we're going to take the mean, 0.795, and we're going to add and subtract 2 of the standard deviations. 0.795 plus 2 times 0.085. This one does not tell us to round. So I got 0.965, and then I'm going to do that again. 0.795 minus 2 times 0.085 is 0.625. So my interval goes from 0.625, comma, 0.965. This is the lower number, this is the higher number, and then the interval contains everything in between. Part B says the company will continue to manufacture both types of hockey pucks if it is reasonable to assume that the true proportion of customers who buy both types of hockey pucks is above 0.6. Using the interval from Part A, explain whether or not the company should continue to produce both types of hockey pucks. So basically, is it likely that you're going to get a true answer above 0.6? Where is 0.6? I know 0.6 is outside of the interval, but they're saying above 0.6. Is it likely that you're going to get an answer that's above 0.6? I would say yes, because majority of this interval is above 0.6. I know that from 0.6 to like 0.624 is outside the interval, but most of this interval is, like, there's more of the interval that's above 0.6 than it is in the interval than it is outside the interval. So this is kind of weirdly worded, and instead of giving you like one number to test, you had to like think about what above 0.6 means. But I would say yes, they should, if it is reasonable to assume. So yes, it's reasonable. Because the 95% confidence interval contains many values above 0.6. So it is likely that the true number is in this interval, and this whole interval is above 0.6. 11 says a company wishes to determine the cooking time for 1 pound of spaghetti. The company's technicians cooked 1 pound of spaghetti and recorded the time needed for the spaghetti to be ready to eat. Repeating this process 35 times resulted in an approximately normal distribution with a mean, so there we go, mean of 9.82, standard deviation of 1.4. In which interval should the middle 95% of cooking times fall? So mean is 9.82 plus or minus 2 of the 1.4s. I'm just making sure these are all minutes, not giving me weird like minutes and then seconds. So 9.82 plus 2 of the 1.4s. Whoops. Sorry, I just typed that in wrong. Okay, 12.62. And then 9.82 minus 2 times 1.4, 7.02. So that would be option 2. All right, next page. 2 classes of students were entered into an experiment to see whether using an interactive whiteboard leads to better grades. It was observed the mean grade of students in the class with the interactive whiteboard was 0.6 points higher than the class without it. To determine if the observed difference is statistically significant, the classes were re-randomized 5,000 times to study these random differences in the mean grades. The output of the simulation is summarized in the histogram below. Determine an interval containing the middle 95% of the simulation results. Round your answer to the nearest hundredth. Here we go again. So we're going to take the mean, 0.01, plus or minus 2 times 0.38. 0.01 plus 2 times 0.38 is 0.77. And then 0.01 minus 2 times 0.38 is negative 0.75. So negative 0.75, comma, 0.77. This says to round to the nearest hundredth. These are already to the nearest hundredth, so I didn't have to worry about that. Does the interval indicate that the difference between the class's grades is significant? Explain. We don't know what this is. It's in the blurb. If you don't know what they're talking about, you have to go back and read. So let's find what they're talking about. The difference between the class's grades. It was observed that the mean grade of students in the class was 0.6, there it is, 0.6 points higher. Right, there's only two numbers up here anyway, and this one says like this is how many times they're doing the simulation. So the only other number we have, but it actually says that. It was observed that the mean grade of the students in the class with the interactive whiteboard was 6 points higher than the class without it. That is the difference. One of them is 6 points higher. So 0.6. So is it significant? Significant means unusual. So they're asking us, is it unusual? Is 0.6, which was this, is that unusual? No, 0.6 is in the interval. So 0.6 is not significant. It's not unusual because 0.6 falls inside the 95% confidence interval. Okay, now make sure you're using the wording from the question. So this question said significant, so I made sure I used the word significant in this. Another one said unusual, so I used unusual. Another one said reasonable, so I used reasonable because I want the person who's grading my test to be sure that I know what I'm talking about, okay? I don't want there to be any like wishy-washy stuff. Could you use different language? Sure, but as a hard and fast rule, just use the language from the question to make it easy. All right, last one. An app design company believes that the proportion of high school students who have purchased apps on their smartphones in the past 3 months is 0.85. A simulation of 500 samples of 150 students was run based on this proportion, and the results are shown below. So there's 500 dots on this diagram. You got the mean and the standard deviation again. That's what we're going to use for a confidence interval. Suppose a sample of 150 students from your school showed that 88% of students had purchased apps on their smartphones in the past 8 months. Based on the simulation with the results from your high school, give the app design company reason to believe their assumption is incorrect. Explain. Now, whenever you see these questions, I would say like a lot of times they use like 95%, but there have been a couple where they didn't actually use that wording with the 95%. That doesn't mean you can't make a confidence interval. We are going to solve this one using a confidence interval. So when in doubt, if you see a simulation like this and mean and standard deviation, just do your confidence intervals just so you have it. 0.852 plus or minus 2 of the 0.029s. So 0.852 plus 2 times 0.029, that gives us 0.91, and 0.852 minus 2 times 0.029, 0.794. So my confidence interval is 0.794 to 0.91. Okay, so the app design company believes that the proportion of high school students who have purchased apps on their smartphones in the past 3 months is 0.85. This down here says, suppose a sample of 150 students from your high school showed that 88%. So here, this is talking about 8.85. That's 85%. So this simulation is really dealing with percentages if you think of it that way. So this simulation was dealing with the fact that the company thought that the that the number of students who have purchased apps on their smartphones was 85%. We got a confidence interval of 0.794 to 0.91. If it's more useful, you can think of that as percentages like 79.4% and 91%. Alternatively, you could just convert this 88% into 0.88 and go from there. So we want to know, based on the simulation with the results from your high school, give the app design company reason to believe their assumption is incorrect. So 0.88, does that fall inside or outside of the confidence interval? So 0.88 falls inside the 95% confidence interval. So it says, would the results from your high school, so the 0.88, give the app design company reason to believe their assumption is incorrect? No, it's not a significant result. So the 0.88 is just like something that's very likely. So it is not significant. It does not give the company reason to believe it's incorrect. I'm just trying to use the words from the problem. I feel like not significant would probably be enough, but no, let's just be clear. All right, that is confidence intervals. So majority of the time, make a 95% confidence interval and then decide if something is in or out of the interval, and that's going to tell you if something's likely or unlikely to happen.